3 lesson 4 now, domain and range, which we've already talked about. So let's see what you remember. Domain goes with what? X or Y? X. Good. Then range goes with Y. Domain, think X. Range, think Y. Domain is your possible values laterally on the x-axis. Range your possible values up and down on the y-axis. Okay? So the range is exactly what a range means. What's the range of values you can have? Domain's the domain for the range of values you can have for x. So the x-intercept of a graph relation has a what coordinate of 0? This is what we just learned. Y. The y-intercept of the graph has a coordinate of x is 0. That's why I said in that very first practice problem you were doing, you make x 0, solve for y. Okay? So domain of relation is set up to all possible values which can be used for an input or the independent variable x. So again, domain goes with your inputs and your independent variable, which is x to us. Okay? That's the main meat of what we're talking about here. The range is a relation to a set of all possible outputs and the dependent variable y. Okay, so range goes here, domain x. In lesson 2, we described relation each of the following forms. So this was yesterday, with words, a table, ordered pair, mapping diagram, equation, and a graph. So list the domain and range of the following set of ordered pairs. I'll do this one. Domain is 1, 0, 3, 5, -3. Those are my possible x's. So that's my domain. I grabbed all the x values, right? Because in the terms of points, this is 1, 0, 3, 5, -3. I got it here, here. Those numbers are my domain. That's my x's. My y's, so my range, is the other numbers. 2, 5, 8, 9, and 2. That's my range. Okay, is that simple enough? Okay, so what's the domain for part B then? What do you think the domain is, Travis?
3, 0, -3, 3.
Okay, good. Perfect. And then Luke, what about the range?
3, 3, 0, 9.
Okay, good. So one thing, you do not have to list a number multiple times. So if it's listed multiple times, you just put it once. Okay?
Why?
Because there's no reason to put it more than once because we've already accounted for it as its range. So 3 is in the range, and 3 and 3. We don't need to know how many 3s, just 3 is a part of our range as a number. Does that make sense? So you don't have to list it more than once. So there's 1, 3, 2, 3, 3. There's 4. List it once with a 9. Okay? Here we go. In each case, state the domain and range based by the graph. Okay? Take a look at this here. So it's giving you kind of points here. Okay, so let's talk about the difference between the pictures first. What's the difference between, like, they're obviously the same V shape. It's an upside down V. But what's the difference between A, B, and C? Okay, good. One's dotted. Therefore, it's not connected. That means these are specific points. So this is an example of shoes. We can't have half a shoe, so we can't draw a line through it. This has a line through it, so there is decimals. This one keeps going forever. It doesn't stop. That's what the arrows mean. This one, specific points. This one, continuous line with endpoints. Continuous line with no endpoints. Do you see that's 3 differences? Now, how does that relate to domain and range? Well, the domain, the range, is just the points here. So this one would be, look, my point for x here is -4, -3, -2, -1, 0, 1, 2, 3, 4. Eventually. Okay? Eventually. We'll write them all for now, but over time we're going to show a shorthand way. The range is 0, 1, 2, 3, 4, 3, 2, 1, 0. So 0, 1, 2, 3, and 4 for the range. This is for picture A. I got those because those are my y values. If you're lost, this point right here is -4, 0. This point here is -3, 1. All these points, you know what they are. You can write them in, and that's where I got these. -4, -3, -2, etc. So we could write specific numbers because we had specific points. Do we have specific points for B? No. I spend my whole life writing all the possible numbers in there because there's an infinite amount of decimals in here. I can write decimals forever. So what we do in this case is we write it as an inequality. So what's the smallest x in this graph? -4, not negative, it's -4. It's one. And the biggest one? 4. -4 to 4. So you write it like this. X is bigger than or equal to -4, less than or equal to 4 for the domain. X is bigger than -4, less than 4. That's an inequality. You can write it with 2, so if you're not good at putting them together, this is the greater than sign. You can write it like that, and you can write it like that. You can write it 2 different ways if you want as well. X bigger than or equal to -4, X less than or equal to 4. Okay? Questions? So the range, what's the highest point here for y? 4, what's the lowest? 0. So your range is bigger than or equal to 0, less than or equal to 4. That's your range for that one. Okay, and now we're going to see what changes with the one on the far right. Yeah, it's a little tricky. So let me ask you this. On this one, can anybody come up with so this goes forever, right?
Yeah.
And this goes forever. Is there any x's we're not going to use? Is there any holes, gaps, anywhere where x is not being used? What's that? Above 4? What do you mean, like past here? Oh, y, yeah. So we're talking about just the x. Okay, so not a trick question, guys, but everywhere, this is the x-axis, there's going to be a value for x because it goes forever this way and forever this way. What that means for domain, this is one of the more common ones, x is all real numbers. So it's like an R with a line through it. All real numbers. So if x can be everything, it's called all real numbers. You can also write all reals if you want. It's fine. I just use that R there. It's just a little math symbol. Okay, all real numbers. Is y all real numbers? Right? This is what you're talking about. So range, so y is going to be what? Because there's not y's up here. There won't be, right? Because it's forever going down. So the highest point is what he said. It's 4 and less. So we want y less than or equal to 4 for the range. 4 is the highest point, and we want everything below that. Okay? It's a really, really important page here for understanding. If you didn't understand something there, please ask now or ask me later, I guess. But it's good to ask questions on the video. No questions? Okay. All right. Okay, so states of domain and range are the following. Okay, Andy, what do you think for A? What's the domain for A? Okay. Yeah, Caleb? All real numbers, correct. It's all real numbers because it goes, the arrows signify it's going forever in this direction, so all x's will work. There will be an x for all of them. Okay. Maddie, you want to take a shot at the range? So range is y. Okay, so good. So 1, 2, 3. So that's what all he's talking about right here is -3 for the y. So it's going to be this number and above, which means greater than. So it's y greater than or equal to -3. So the thing you have to figure out is you have to go and look and see, like, okay, where's the limit? So for y, the limit is here. There's nothing below here, right? There's nothing down here. Okay, what's this lowest point? And that's what Ollie said, -3. That's correct. And then it goes forever up. So you want everything bigger than -3 is in the range. 12, 300, 1,000, those all work. -6, no. Okay? Domain, forever it goes this way and this way, so everything's good. Okay? Ooh, this one's a tricky one. Circle. Okay, Noah. Aw. Okay, so Noah, just think about domain. So where is the restrictions for x? Like how far can x go? 4. Okay, yeah, 4 for this side. Good. So it's good. So it's between those two, right? So it's x is between 4 and -2. -2 and 4. That means greater than -2, less than 4. Because it's between here, right? There's nothing out here, so it's right in between here. Okay, how about the range? Let's see here. Aiden, you want to take a shot at the range? It's another between, right? 'Cause it has to be, it's between here and here.
3 and 1.
Right. Yeah, let's go -3 and 1. So I'll say 3 because right here it's pretty, I think it gets a little lower right there. And just to let things be a little bit easier. So like that. Y is greater than or equal to -3 and less than 1. That's good. I'm doing everything in x and y just because that's just kind of the status quo, but this one was technically p, so we just put a p there. This is technically t, so you put a t there, but that's okay. Okay, so now we're doing it from a mapping diagram. Exciting stuff. So remember, these essentially right here, these are our x's, these are our y's. So my domain is 1, 2, and 3. It's all the x's. Okay, what's my range, Ridge? 2 and 6, that's it. Only have to do, notice that 1 and 3 go to 6, but they only listed it once. Okay, same idea. Now we're talking in words here, a circle with the center of -2, 3 with a radius of 3. So it's going to be just like the picture above. The center is over here, -2, 3, has a radius of 3. So it's going to go 1, 2, 3, right there. 1, 2, 3, right there. 1, 2, 3, right there. And 1, 2, 3. All I'm doing is that was the center. The radius, I just went all directions 3, because that's a radius. So then your circle would be something like that. So what's the domain and range of that guy? Well, based on my points, my domain, again, it's going to be a circle, so it's between. So my domain here is, yeah, -5 to 1. This distance here. Yeah. My range will be 6 to 0. Okay. Almost done. You guys are doing good. Any questions on that? Okay. All right. Draw the graph of a relation. Has a domain of all real numbers, a y less than or equal to 2 for all real numbers. So when it says all real numbers, that means that the numbers less than 2 have to be real. That's all that means. And this just means everything if that's all you have. So the notation means less than or equal to 2, all real numbers though, which means all the real numbers less than 2. This just means everything. So go ahead and try to draw those 2 examples. I'm going to give you some time to try to draw that on your own. Here, I'll do the first one. Only one x-intercept. Okay, so I'm going to take my picture here. I know my range is less than or equal to 2, so I can have nothing above this line for my picture. Nothing can be above there. Okay, and it has one x-intercept. Okay, so it's going to be kind of a little bit of a weird picture, but I have to draw something along the lines of just something like that, and then just we'll say it flattens out. Okay, so this is my range is less than 2. My domain, everything's okay. I have to have arrows. If I don't have arrows, that means it's not okay. Try the same thing, but now you can have 2 x-intercepts. Try this. You try the 2 x-intercepts one. Where? 1? Because this line's going parallel. They're not going to cross. If I go just straight up, then I will not be less than or equal to 2 for my range, because I'll be above 2. I flattened out because of the 2. These are great questions, Aiden. Good questions. Anything else? Okay, try one with 2 x-intercepts. Try one with 2 x-intercepts. I'll give you a couple minutes here. Sorry, let's get this done here. You guys are losing a little bit of focus. Okay, the key is, again, I can't be anywhere above 2. That's what that tells me. Nowhere above 2. But I need 2 x-intercepts, so I need a bend or a v. So a couple options. I can do this one. That's above 2. It's a little too high. Yeah, parabola. Okay, right there at 2. Or I can do a v. Both work. But you have to have your arrows. That signifies it keeps going forever, which means all reals for x. They have 2 x-intercepts. 1, 2, 1, 2. Okay. Any questions on that? Okay, explain why it's not possible to draw a graph which has a domain of all reals, y less than 2, and has no x-intercepts. Well, because if it's all reals, yeah, like it would not be able to do, we'd be here. Our range is less than or equal to 2, but has no x-intercepts. That means it has to be like something like this. Like it just wouldn't be realistic in doing so. So it's saying how would you be less than 2 and have no x-intercepts? It's pretty much saying you have to cross the x. That's what it's saying. Because this one we cross once, these we cross twice. What would you draw less than 2 that wouldn't cross? A what? A straight line? Like this way? Works for me. That's a good job.
Can I say this wrong?
What's that?
This is explaining why it's not possible.
Just say you can draw a straight line.
That's right. That's possible there.
Yeah, that works.
That works.
Send that to the government and say your book is wrong.
Touche.
Can I take a picture of it?
Sure. Okay, high school football teams hosting a banquet to celebrate the winning championship. The caterer charges a setup fee of $500 plus 20 per person. That equation can be represented as 500 plus 20 in. Represents the cost of hosting the banquet for n people. Make a table of values of 8 entries for a minimum of 100 maximum of 500 people. So make a table of value with 8 entries for a minimum of 100 and a maximum of 500 people. So that means you're going to do 100 as your minimum, 500 is your max, and you're going to do values in between. Let's see what ones I have in my notes here. So okay, so a couple things you need to understand. And if you don't know this yet, then you're behind. These are my inputs. These are my independent values. These are considered my x values. Okay? These kick out my outputs. These are all my outputs. How do you get your outputs? By putting this in for n. 500 plus 20 times 100. Okay? So this one would be 2,500, 4,500, okay, 300, 6,500, 350 is 7,500, 400 is 8,500, 4,500 is 9,500, and then okay, 10,500. So now it's going to ask us to plot these as ordered pairs. They're x and y's. They're coordinates. Okay? That's a good question. Oh, sorry, you didn't have it yet? Just going up by 100 each time. Or 1,000, I mean. Okay, so plot the 8 ordered pairs. So yes, that's the question, Ollie, is what do we make our graph by? Okay, well, we're up to, our lowest is 2,500. Our highest is 10,500. So maybe it's smart to go by maybe like 500s. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Yep. Oh, okay, 5,000. And then we go here. Going by 500s.
Oh, I thought we were like every 5.
Okay, so there's going up by 500s every time. So like I'm talking about every square. So 500, 1,000, 1,500, 2,000, 2,500.
Oh, okay.
The bottom, what would it make sense to go by?
50.
Yeah, probably 50s. You can probably even go by 25s if you wanted, but I'll go by, let's see, I'll go by 25s. So 1, 2, 3, 4, that's 100. 1, 2, 3, 4, 200. 1, 2, 3, 4, 300. 1, 2, 3, 4, 400. 500. Okay, that's all we need. And then we're going to plot our points now. 100 is 2,500. Right there. 200 was 4,500. 250, so that would be right there, was 5,500. 300 was 6,500. You can kind of see the linear relationship taking place. 350 was 7,500. 400 was 8,500.
So is it like every 5 is 100?
Yeah. Wait. Every 4 what I did. 1, 2, 3, 4. 25s. I don't know. I think 25s are easy to count. You can go every 5 if you want, though. That just means yours are worth 20 each time. Okay. 450, we're at 9,500. So we're at 8 right there. And we are right there. Okay, so we can see our linear relationship, which is good. So it says there for C, if all possible ordered pairs were plotted on the grid, state the domain and range of the relation, explain why there are restrictions on both. So what are the restrictions? What are they talking about? Well, the restrictions they gave to us, they said the max we can have is 500, the minimum we can have is 100. So that's a domain for us. Our domain is between 100 and 500 people. They told us that in the problem. They said the lowest amount of people you can have is 100, the maximum is 500. And then our range, you would list these prices. Okay? So you would list them. So you don't have to list them all, but you can just say your range would be, just do a couple. It would be 2,500, 4,500, and then you just do ... to the 10,500. Okay, and that is it for the notes.